Welcome to The Explainer. I am your host, your resident strategist for all things Cambridge computer science, and I am absolutely thrilled you're here today. We're tackling something incredibly vital for your exam journey. Imagine the clock is ticking down, the tension is building, and you flip the page to a massive multi-part scenario question. This is the reality for thousands of candidates every year. Today, we're looking specifically at a topic that trips up countless students: data management, and more specifically, maintaining a data dictionary. Now, whether you are tackling the AS and A-level 9618 syllabus, or you're laying the groundwork with IGCSEs like 0417, 0478, 0983, 0984, or 2210, the core strategic principles we are going to cover today are completely universal. Think of this explainer as your definitive, no-nonsense exam strategy masterclass. We are going straight to the source material, pulling back the curtain on exactly what Cambridge examiners are aggressively looking for. Let me introduce you to two completely hypothetical but very realistic students taking a classic past paper question, let's say from syllabus code 9713. First, we have Alex. Now, Alex overloads their answers with raw computer science facts. They just dump every piece of memorized data dictionary trivia onto the page, completely ignoring the context. Zero analysis. Then we have Sam. Sam is constantly watching the clock, rushing through, and completely missing the command word requirements. They write a single fragmented sentence and hope for the best. By the end of this session, you are going to see exactly why their answers are covered in red pen marks and how we are going to transform those into green check marks. So get focused, get ready, and let's decode how to secure top marks in your exam.
Now, you might be wondering, why dedicate a whole focus session just to data management and maintaining a data dictionary? Why not cover everything? Well, this isn't just a minor subtopic you can comfortably skim over the night before the exam. Look at the high stakes here. This single area commands approximately 15% of the total marks in Paper 2. That is a massive, grade-defining chunk of your final score sitting right there. If you can master this, you are building a formidable foundation. Think about our students Alex and Sam. When they mess up their data dictionary definitions, when Alex writes a textbook paragraph about metadata that doesn't answer the question, or when Sam just writes integer without specifying field length or validation, they are literally throwing away 15% of their grade. The examiners treat this specific topic with incredibly high importance because it tests your fundamental logic and organization. It's the architecture of your entire database. If the foundation is flawed, everything else crumbles. We need to fiercely secure that 15% by giving the examiners exactly what they are asking for, without the fluff and without the panic.
Section 1. Core Principles and Foundations. Before we can start executing complex, high-scoring answers, we need to really dig into the academic benchmarks and understand what Cambridge examiners actually demand from top-tier candidates. Now, this is a question posed directly by senior examiners year after year. Why do students find the distinction between similar concepts so incredibly hard? It's a massive pain point. When you're dealing with a data dictionary, defining data types, establishing validation rules, setting primary and foreign keys, the terminology can start to blur together under exam pressure. Students like Alex memorize facts but fail to understand the nuanced differences between a simple flat file structure and a robust relational database validation method. They confuse an input mask with a validation rule. The examiners note that the assessment framework aggressively prioritizes analytical depth over superficial breadth. Simply knowing the vocabulary isn't enough anymore. You need to decode the command words. Are they asking you to state, describe, explain, or evaluate? Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSCME to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. Command word decoding is your first line of defense against losing those easy marks. True mastery requires systematic analysis and evidence-based reasoning. The syllabus explicitly emphasizes that top-performing students don't just regurgitate facts. Instead, they demonstrate a deeply connected conceptual understanding. What does that mean for you? It means they can take the core principles of data management and transfer them seamlessly to completely unfamiliar context. When the exam throws a strange, novel scenario at you, like managing data for an automated greenhouse or a regional drone delivery service, your systematic analysis is what saves you. To do this, we use the PEEL framework: point, evidence, explanation, link. Top students structure every single analytical answer using PEEL. You make your point about the data dictionary, say, selecting an appropriate data type. You provide evidence from the given scenario. You write out an explanation of how that data type functions. And finally, you link it back to the overarching goal of the system. We are going to put a 30-second timer on the clock in just a moment for our interactive segment, and I want you to spot which of our sample answers actually follows this PEEL structure. It's an absolute game changer for your writing.
Section 2. The step-by-step procedural framework.
So how do we actually apply that logical reasoning under the crushing pressure of an exam? By using an exact, standardized sequence that practically guarantees maximum method marks. This is your computer science success blueprint. First, deconstruct the question. Highlight the command word. Second, extract the relevant data, paying special attention to binary representations or provided data tables in the scenario. Third, select your analytical framework. Decide which data management principles apply. Are we validating? Are we indexing? Fourth, execute with clear notation. This means showing you're working and performing the necessary calculations step by step. And fifth, present your final answer using the absolutely correct terminology in the format they asked for. Right now, we are going to do a live rewrite. We are putting 60 seconds on the clock. Take Sam's rushed answer from earlier, where they just wrote pet ID, integer, for a veterinary clinic database. Apply the 5 steps. Deconstruct. The question asked to define the primary key with validation. Extract. It's a vet clinic. Execute and present. Pet ID must be configured as an alphanumeric string, length 6, serving as the primary key to ensure unique entity identification, with a format check validation rule to prevent duplicate pet entry. Boom. Red pen transforms into a green check mark. That is how you secure the bag.
Practical application in maintaining a data dictionary heavily involves algorithmic thinking. This is the engine under the hood. When you are asked to design algorithms or implement solutions based on your data dictionary definitions, you must rely on step-by-step decomposition. Break the massive, intimidating problem into small, manageable chunks. Then, ensure you are making the appropriate data structure selection. If you choose a one-dimensional array when a two-dimensional array or a linked list was required by the scenario, your whole algorithm falls apart. Next, it requires efficient code implementation. Examiners are looking for clean, logical loops and precise conditional statements. Finally, rigorous testing. You have to prove your code works against the constraints of your data dictionary. These aren't just fancy buzzwords to throw into an essay. These are the exact, measurable programming skills examiners are grading you on when evaluating your performance. You have to think like a compiler.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Section 3, Critical Examiner Warnings. Now that we have the ideal framework, we need to talk about what happens when things go horribly wrong. We are stepping into our interactive workshop, Challenge 1, Data Scan. Look closely at the complex data source we're pulling up. I'm starting a 60-second timer right now. As that timer counts down, your goal is to extract the core trend from this data dictionary extract. What you're looking for is the difference between a vague, generalized answer and specific, context-driven technical details. Examiners explicitly report that answers on data management are far too often vague. You cannot just write that a data dictionary stores information about data. That won't cut it. Examiners demand technical precision. Notice in our data scan, the top-tier answer doesn't just say it holds data. It specifies the exact metadata. It calls out the field names, the precise data types, the character lengths, the default values, and the exact validation rules. 30 seconds left. Are you seeing how this specific answer ties every technical detail back to the veterinary clinic context? It mentions pet weight limits and appointment date formatting. 10 seconds. Time's up. If your eyes naturally gravitated toward the specific, context-driven details, you are already thinking like a top band candidate. Let's move to Challenge 2, Find the Flaw. I am going to show you a flawed sample paragraph, and you need to identify exactly which sentence is bleeding marks. Here are the top 3 mistakes cited in principal examiner reports to help you spot it. Number 1, answers are too vague. Number 2, students forget to check boundary conditions and edge cases. And number 3, answers ignore the given context. Okay, here is the paragraph. The system uses an integer for the age field. The validation rule ensures the number is positive. A text field is used for the name. Spot the flaw? Yes, it's the validation rule sentence. It totally forgets boundary conditions. Just saying positive isn't enough. Is the upper limit 100? 200? You must define the exact boundary condition, like greater than 0 and less than 30 for a pet. Now for Challenge 3, Speed Writing. You have 30 seconds to write one perfect peel paragraph correcting that flaw. Ready? Go. Point, define the exact boundary. Evidence, use the vet clinic context. Explanation, detail why an upper limit prevents erroneous data entry. Link, connect it back to database integrity. 10 seconds, wrap up that final linking sentence. And stop. If you successfully applied Peel to fix an edge case within context, you are mastering this framework. Section 4. Evaluative thinking for top marks. Avoiding mistakes is fantastic, but we are here for the absolute top grades. We want those A stars. Top-scoring candidates don't just build a solution, they ruthlessly evaluate it. You need to implement our third rule, the time management matrix. In your exam, you need to quickly allocate time to evaluate alternatives. Could a different data structure work better? You need to consider trade-offs and intensely analyze limitations. For example, evaluating algorithm quality requires you to identify both time complexity and space complexity and discuss their direct effect on overall system performance. Finally, you must justify your decisions with hard evidence. Why did you choose a fixed-length string over a variable-length string for the product code? If you can articulate these trade-offs and limitations clearly, showing the examiner that you understand the real-world implications of your data dictionary choices, you are hitting the highest assessment bands Cambridge has to offer. You are showing them you are not just a student, but a systems architect.
I want to leave you with this massive examiner alert. This is a direct quote, practically a lifeline thrown to you from the grading room. Even if your final answer is wrong, method marks can save you. I cannot emphasize this enough. The examiners explicitly state that students lose tragic amounts of marks by simply not showing their working. If you mess up a final calculation under pressure, but you clearly showed your algorithmic thinking, your step-by-step decomposition, and your clear notation on the page, you will pick up method marks. The process is just as important, if not more important, than the final destination. Do not leave your brilliant analytical process invisible in your head. Put it on the paper. Let the examiner see your logic. That is how you build a safety net that guarantees you don't drop a whole grade boundary over one silly arithmetic mistake.
We have reached the end of the system. We've decoded the command words, applied the Peel framework, and mastered the time management matrix. Our mark potential progress bar is hitting 100%. Now, the real work begins. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing, keep evaluating, and I will see you in the next strategy session.